Relational and distributed databases. What is a relational database? A relational database refers to a database that stores data in a structured format using rows and columns. A relational database organizes data in tables, also called relations, which can be linked or related based on data common to each. This capability enables you to retrieve an entirely new table from data in one or more tables with a single query. It also allows you and your business to better understand the relationships among all available data and gain new insights for making better decisions or identifying new opportunities. For example, imagine your company maintains a customer table that contains company data about each customer account and one or more transaction tables that contain data describing individual transactions. The columns or fields for the customer table might be customer ID, company name, company address, and so on. The columns for a transaction table might be transaction date, customer ID, transaction amount, payment method, and so on. The tables can be related based on the common customer ID field. You can therefore query the table to produce valuable reports such as a consolidated customer statement. Popular relational database management systems include MySQL, which is the most popular open source SQL database. It is typically used for web application development and often accessed using PHP. PostgreSQL, which is an open source SQL database that is not controlled by any corporation. It is also used for web application development. Oracle DB, SQL Server, and SQLite. The relational data model provides conceptual tools to design the database schema of the relational database. The relational model describes the data, relationship between that data, data semantic, and constraints on the data in the relational database. Relational model concepts include attribute, which is basically a column. For example, a student entity may have name, class, and age as attributes. Table, which is also a relation. A table has two properties, rows and columns. Rows represent records and columns represent attributes. Tuple, a tuple is one record. Relation schema, a relation schema represents the name of the relation with its attributes. Degree, the degree of a relation is the number of attributes it contains. Cardinality, the cardinality of a relation is the number of tuples it contains. Primary key, the primary key is a column or set of columns whose values uniquely identify each row in the table. Advantages and disadvantages of relation database. Advantages: 1. Ease of use. The revision of any information as tables consisting of rows and columns is much easier to understand. 2. Flexibility. Different tables from which information is to be linked and extracted can be easily manipulated by operations such as project and join to give information in the form in which it is desired. 3. Precision. The usage of relational algebra and relational calculus in the manipulation of relations between the tables ensures that there is no ambiguity, which may otherwise arise in establishing the linkages in a complicated network type database. Disadvantages: 1. Performance. A major constraint and therefore disadvantage in the use of relational database system is machine performance. If the number of tables between which relationships to be established are large and the tables themselves affect the performance in responding to the SQL queries. 2. Physical storage consumption. With an interactive system, for example, an operation like join would depend upon the physical storage also. It is therefore common in relational databases to tune the databases, and in such a case, the physical data layout would be chosen so as to give good performance in the most frequently run operations. 3. Slow extraction of meaning from data. If the data is naturally organized in a hierarchical manner and stored as such, the hierarchical approach may give quick meaning for that data. Distributed databases. What is a distributed database? A distributed database is a database that consists of two or more files located in different sites, either on the same network or on entirely different networks. Portions of the database are stored in multiple physical locations, and processing is distributed among multiple database nodes. Types of distributed databases. 1. Homogeneous. In a homogeneous distributed database, all the sites use identical DBMS and operating systems. Its properties are: the sites use very similar software, the sites use identical DBMS or DBMS from the same vendor. Each site is aware of all other sites and cooperates with other sites to process user requests. The database is accessed through a single interface as if it is a single database. 2. Heterogeneous. In a heterogeneous distributed database, different sites have different operating systems, DBMS products, and data models. Its properties are: different sites use dissimilar schemas and software. The system may be composed of a variety of DBMSs like relational, network, hierarchical, or object-oriented. Query processing is complex due to dissimilar schemas. Transaction process is complex due to dissimilar software. A site may not be aware of other sites, and so there is limited cooperation in processing user requests. Types of distributed databases. 1. Replication. The entire relation is stored redundantly at two or more sites. If the entire database is available at all sites, it is fully redundant database. Thus, systems maintain copies of data. It increases the availability of data at different sites. Query requests can be processed in parallel. Challenges include the need to constantly update changes across all sites. This is a lot of overhead. Concurrency control becomes way more complex as concurrent access now needs to be checked over a number of sites. 2. Fragmentation. The relations are fragmented, i.e., they are divided into smaller parts, and each of the fragments is stored in different sites where they are required. It must be made sure that the fragments are such that they can be reconstructed to the original relation, i.e., there isn't any loss of data. Fragmentation is advantageous as it doesn't create copies of data, and consistency is not a problem. Fragmentation of relations can be done in two ways. 1. Horizontal fragmentation, splitting by rows. 2. Vertical fragmentation, splitting by columns. Advantages of distributed databases. 1. Management of data with different level of transparency. Network transparency. This basically refers to the freedom for the user from the operational details of the network. These are of two types: location and naming transparency. Replication transparencies. It basically made the user unaware of the existence of copies, as we know that copies of data may be stored at multiple sites for better availability, performance, and reliability. Fragmentation transparency. It basically made user unaware about the existence of fragments. It may be the vertical fragment or horizontal fragmentation. 2. Increase the reliability and availability. Reliability is basically defined as the probability that a system is running at a certain time, whereas availability is defined as the probability that the system is continuously available during a time interval. When the data and DBMS software are distributed over several sites, one site may fail while other sites continue to operate, and we are not able to only access the data that exists at the failed site, and this basically leads to improvement in reliability and availability. 3. Easier expansion. In a distributed environment, expansion of the system in terms of adding more data, increasing database sizes, or adding more processor is much easier. Disadvantages: complex software. Complex implementation costs more in terms of software cost compared to a centralized system. Additional software might be needed in most of the cases over a centralized system. 2. Increase the processing overhead. It costs many messages to be shared between sites to complete a distributed transaction. 3. Data integrity. Data integrity refers to the validity and consistency of stored data. Integrity is usually expressed in terms of constraints, which are consistency rules that the database is not permitted to violate. Enforcing integrity constraints generally requires access to a large amount of data that defines the constraints. In a distributed DBMS, the communication and processing costs that are required to enforce integrity constraints are high as compared to centralized system. This is spiders.co. Please do follow us on Instagram at _spiders.co_. Thanks for watching.